So we're continuing with Chapter 6 at the beginning of this semester, and Lesson 6.5 covers linear inequalities. And the name explains exactly what it is. Linear, so you're going to be graphing lines. Inequalities, so you're dealing with inequalities instead of linear equations. And if you look at example 1, it asks you to graph y is less than 2x plus 3. So what you're looking at on these is actually several different points that will work, a huge amount of points that will work here. Because instead of just being points on the line that are true for this equation, now you're going to have all these points on your coordinate plane that are true for the equation. So I'm going to walk you through this. If you are pretty good at graphing linear equations, you don't have much to learn when you go to graph linear inequalities. What you're going to do is you're going to graph the equation that would go with it first. It's called your boundary line. So you would look at this as y equals 2x plus 3, and that's called your boundary line. So my boundary line is y equals 2x plus 3. Hopefully most of you notice this is already in slope-intercept form, not standard form. Slope-intercept form we can graph using our y-intercept and our slope. So our y-intercept is 3 and our slope is up to right 1. Now the only thing you have to be careful of that you kind of need to make like a mental note about before you go to graph this, you have to apply the rules from chapter 3 that most of you hopefully remember. It's a little different version of the rule. But when you have a less than sign and you were graphing inequalities earlier this year, you had an open dot. When you had an or equal to sign, you had a shaded dot or a closed dot. You're going to do the exact same thing when you graph these boundary lines. You're going to look, and if it's not or equal to, then you're going to have a dashed line. And you might want to even make yourself a note about that so you know. If it is or equal to, you're going to draw a solid line, and I'll explain more about that once we get it graphed. So when we go to graph this, we're going to start at 3 on the y-axis, and then we're going to go up to right 1, up to right 1, up to right 1, up to right 1. If you want to, now you can go down 2 and left 1, just to keep that pattern going through your whole graph. Now you're going to connect these lines, but you're going to use a dashed line. And you can still use a ruler, but you would just pick up your pencil every once in a while. Don't forget your arrows at the end. The reason you have a dashed line here is because this boundary line, all of your solutions to this are either going to be on this side of the line or they're going to be on this side of the line. But they are not going to include the line. And the reason they're not going to include the line is because it's not or equal to. If it was or equal to, then it would be a solid line shaded in, which means it's part of your solutions. So now you're probably asking yourself, well, how do I figure out which side to shade? Very simple. You've been doing this all year long. You're going to pick a point that is either on this side of the line or on this side of the line, and you're going to plug it in, and you're going to find out if it's true or not. Whichever side is true is the side that's shaded, because remember, you always shade the possible answers. Even earlier this year, that's what we were doing. I always prefer to pick a point that's really easy to plug in, something like 0, 0, if the line's not crossing through it. Pick the easiest point you possibly can to plug in, see what happens, and then go from there. So I'm just going to go ahead and show you right now. If we were to pick up 0 and plug it in mentally, which we're going to show on paper in a minute, 0 is less than 2 times 0 is 0. 0 plus 3 is 3. So is 0 less than 3? Yes, it is. That means that any point on this side that you plug into that inequality is going to be true every single time. Any point that you plug in on this side of the inequality is not going to be true every time. And you can go try one if you want to right now to see. Shaded side is the side that's true because this point 0, 0 was true. It falls on this side of the line, so this is the side that I would shade. And I would go through. Some of you might want to use a highlighter or something, or turn your pencil sideways, and it's all of that. So what I just talked about is right here. Write this in your notes so you see what you can do later. We did it mentally just because I didn't want to move the original equation. But you plug in a point. 0, 0 is always the easiest if the line doesn't go through it. Try it out. 0 was less than 3, so that is my true side. If that had been not true, then I would already know this side was, because there's only two sides. It's one or the other. If you needed to, you could still go pick a point from there. And of course, in this case, it would not be true. But if this originally had been not true, then that side would be true. Go ahead and copy in what's on the left. Hit pause, hit play when you're ready to copy the rest. It's exactly what I just talked about. This is the rest of it. Hit pause, finish copying it, hit play when you're ready to go on. Here's example 2. Write this down, and then we'll go through it. This is just a quick review of graphing one of these types of lines in case you forgot, because they will show up. Remember, first thing you need to do is graph your boundary line, and your boundary line is going to be x equals 2. So the boundary line just replaces the inequality with an equals, and remember, go to the axis that's listed. So x-axis, go to 2, put a dot. That's your starting point. And then remember, it's perpendicular. It's the opposite of the axis there, the perpendicular line to that axis. That's your boundary line. The reason I made the boundary line solid is because it's or equal to. So these are all going to be solutions to that. Any point that falls on that line plugged in here is going to make that true because of the or equal to. If it wasn't true, then it would be a dashed line and there wouldn't be an or equal to there. So again, I pick a point from either the left or the right of this line, either this side of the line or this side of the line. 0, 0 is always easiest, so I'm going to use 0, 0. When there is no y to plug in 0 for, you just don't worry about it. So we plug in 0 for x. Is 0 greater than or equal to 2? Hopefully you all said no, it's not. Because it's not, this is where every year I seem to get kids who are confused. Here's my boundary line. Here's the point 0, 0. This side is the not true side because when I plugged that point in, it was not true. Any point at all, you could sit there all day long and plug in points from over here and they're always going to be a no answer. Everything you plug in over here is always going to be a yes answer because it's got to be one or the other. So it's this side that's true. You can try it now if you want to, otherwise you can just believe that I said if this is my no side, that's my yes side. And it's no because when I plugged in the point 0, 0, which falls there, that was not true. So everything on this side is not true, everything on this side is true. Alright, here's example 3. Write this down and then we'll go through it. Exact same thing here, you're just graphing a linear inequality. Hopefully you noticed as you copied it that this one is not in slope-intercept form. This one is actually in standard form. So when you go to graph your boundary line, you're going to use what we use with standard form, which is intercepts. So I'm going to do a quick review on that with you. Alright, so we're going to use standard form, which is intercepts, to graph the boundary line. So you write your boundary line, 3x subtracting 5y equals 10. And this is where we go with our t-chart. Plug in 0 for x. You end up with 3 times 0 minus 5y equals 10. So you end up with y equals negative 2 once you do all the math there. And then you plug in negative 2 for y. When x is 0, y is -2. And then you do the same thing, but you plug in 0 for y. So now I have 3x subtracting 5 times 0 equals 10. I end up with 3x equals 10, divide by 3, and x ends up being 10 over 3. Or I can make this a mixed number for graphing. 3 goes into 10 3 times with the 1 left over, so 3 1/3. And then that's when y is 0, x is 3 1/3. Now you graph the 2 points that you got, so they should be your 2 intercepts. 0, -2 is 1 point, and 3 1/3 and 0 is your second point. So over 0 down 2 is my y-intercept. Over 3 1/3 up 0, about there, would be my x-intercept. I'm going to have a solid line because it was or equal to. Be careful, that gets me all the time also. Go ahead and plot those points and draw in your solid line. There's my line. Now, there are going to be times when this line crosses through 0, 0. So you can't always use 0, 0, but most of the time it won't. So most of the time you can. We need to figure out, are we shading this side of the line or are we shading this side of the line to make our inequality true? And again, we have the point 0, 0 available. That's always going to be your easiest. So for shading, we're going to go ahead and plug in the point 0, 0, and we're going to see what happens. 3 times 0, subtracting 5 times 0 is less than or equal to 10. 0 subtracting 0 is 0. Is 0 less than or equal to 10? Yes, 0 is less than or equal to 10. So because of that, 0, 0 is my shaded side. So I go where 0, 0 is, that's where it is, so that is my shaded side. And you want to show all of it, or as much as you can to show it goes on forever. Because remember, this graph goes on forever and ever and ever, so that shading is going on forever and ever and ever. All these points from this line going forever up that way are going to be true for this inequality. The other option that you have here is to convert this original inequality to your boundary line where you make it equals, but then you graph it in slope-intercept form. And I'm just going to walk you through that really quickly to make sure you remember it. You don't have to write this part in your notes unless you need practice at this, if you even wanted to. But again, intercepts is so easy, you really have no reason to do this. But just for practice, you need y alone, so you're going to move 3x, and you would subtract 3x from both sides. You end up with negative 5y equals a negative 3x plus 10, and then you divide everything by a negative 5, and you end up with y equals negative divided by negative is a positive, so 3/5 x minus 2. And notice we would start at negative 2 and go up 3, right 5. So if we started at negative 2 and went up 3, right 5, it looks like our line almost matched perfectly there. It's off a teeny bit because my line is off. So that is slope-intercept form if you had wanted to graph your boundary line that way.